Yeah, hi, hello, everyone. Good evening, good afternoon, good morning, wherever, from whichever part of world you are attending this session. So, welcome to Next Gen Data Aspirants community. So, today we are having our speaker Prakash Ravichandran. He is a lead data engineer in Tiger Analytics. He have solid experience in data engineering. Like he has working as a data engineer in Tiger Analytics from the past few years. So welcome Prakash Ravichandran. So the floor is yours.
Welcome,
Yeah,
Ravi.
thank you. Yeah, thank you very much, Suparna. Thank you very much, Ajay Babu. Thank you, Next Gen community. So let me start the session.
Yes.
Hi everyone. Thanks for joining the session. So myself, Prakash, as Suparna said, currently I'm working in Tiger Analytics as lead data engineer, and also previously I worked on big MNCs like Infosys, Cognizant. So I worked with multiple product-based companies which are leading the industries like Adidas, Geo, uh, Tata, Tata Alexi, and so I worked on completely building pipelines from end to end. So let me share my screen. So let me make the session more interactive. So if you have any doubt in between session, just raise the hand so that the organizers will let me know. We'll have it more interactive. I hope the screen is visible. Yeah, Ajay, can you confirm?
Yeah, it's visible.
Yes. Thank you very much. Yeah, so in this session, we are going to discuss about the topic of the philosophy of Azure Data Engineering from the fundamental to practice. So first of all, we have to understand why we are focusing on Azure Data Engineering because so we have multiple roles like Java developer, pattern developer, testing, and everything. So as per the current industry, as everyone know, the job market is mainly focusing on the data driven job roles. As everyone know, the importance of data in the current market and the demand for data experts is growing larger and larger for last 3 to 4 years, as everyone know. And also market is demanding a huge package for data engineers. So literally in the current market, so we can expect around uh, for example, for a Java developer, they can earn up to 15 to 20 lakhs for the 3 to 4 years of experience. But for data engineer, we can expect around more than 30 plus lakhs in the current job market, as everyone knows. So yeah, let's start the session. So for the philosophy of data engineering, so as everyone know, in today's digital era, the data is the most fuel for the each and every company's growth, innovation, and the decision making of each and every companies as well, right? So however, even the raw data alone can bring a little value for the product for the company. The raw data need to be collected, processed, and transformed as per the company's or client requirement to make it more insightful. So let's say we have two companies like company A and B. So let's assume company A is collecting all the previous 5 years of data in the history, and they are planning to grow the company by using the comparative last 6 months of last 5 years of data. Let's say from the history they can able to easily manage that on which month or in which season they are producing the more sales, or in which season they are affecting the sales, which product is moving so much faster than expected. Based on that, they can even predict the upcoming sales as well, upcoming manufacturing plans, everything. So, as everyone know, previously like two companies, in last 3 years, the companies which are focused on mainly on data part, gaining the more number of profit nowadays. Yeah, so this is where data engineering came into picture. Data engineering is nothing but it's so let me give you the definition. Like it's a discipline that bridges a gap between a raw data and their actionable insights. So the data engineering is nothing but we are going to extract data from any kind of source, like it might be a Salesforce app or might be a local system, any cloud, whatever SQL DB might as well. From that, we are going to extract data, and then as per our client requirement, or let's assume our end users are data analysts or machine learning experts, data scientists, for based on our requirement, we have to transform the data, and then we are going to give store data in the respective target environment. So this is what data engineer will do. Not just extracting, transforming, loading data. Apart from we have huge number of tasks to do to make the data more meaningful. So we are not getting the data in a right format, right? So first of all, we do some data cleaning. We have to decide on which column we have to mainly depend on. So we will discuss everything in this session one by one. Maybe after this session, you will get some clear idea about what are tasks driven by the data engineer, what are the skills that you have to learn, what are the things you have to mainly focus on to get more package. Okay. Yeah, in this session, we are going to discuss about the foundation of data engineering, why we are using Azure, because the session is mainly about the Azure. So we have different cloud providers like GCP, AWS, Snowflake, and Azure. So instead of going with some other cloud providers, actually all cloud providers are good. They are giving competitive services, but why we are focusing on Azure? So if you see in current job market, if you have 10 roles for data engineer, out of 10, 5 to 6 job roles will be on Azure, and next 3 to 4 roles will be on AWS, and 1 or 2 openings on GCP. So I highly recommend to focus on Azure tech stack cloud. We will discuss about what is data warehouse, data lake, data lakehouse. Currently in job market, we are focusing on data lakehouse. Each of the architectures having a separate benefits. So based on our requirement, we can choose architectures. So what are the main cloud services, which are main Azure services that we are currently using in the real-time projects? And we will discuss about the Medallion architecture. So we have different architectures in the industry. Can we mute
Yeah, you can continue, Prakash. I muted.
Okay, thank you very much. So in the job market, in real-time things, the Medallion architecture is very, very important architecture that you have to understand to it's in both perspectives, to work in a real-time project as well as to crack an interview. Because whenever you go for the interview, the Medallion architecture concept will be a basic concept. So if you can't explain this concept, so it's quite difficult to go for an interview. Even it's for the data analyst role as well, because they should have some kind of understanding. Whatever role, it's not a matter. But the things that we are going to discuss here, like architectures, data services, Medallion architecture, why Azure, those will be main thing for data engineering, but especially for common for all data experts. Okay, and in final, we will in Databricks we will see how Medallion architecture work in the real time. So I will give you a live demo on that. Yeah. So first of all, let's clear who is data engineer, who is data scientist, and who is data analyst. First of all, you have to understand, because still most of them are most of you guys got confused which role you have to choose. So it's not about the package, it's about your interest. Because if you are, let's say, data analyst role, uh, data analyst is the person who can have data already, the clean data, transform data is already available for them. From the data, they are going to build some dashboards, insights, any reporting tools like Power BI, Tableau, Excel. The person who is working on building a hidden details of data. From data, they will give the previous trends, or they will try to minimally trying to predict the future of the data dashboard. Those are the people called data analyst. So if you see in this image, it's clearly mentioned that they will use these tools, analyzing data to uncover insights and support better decision making things. For example, if we have a data in which we will have past 5 years of data, sales data, as an analyst, they will create a dashboard to draw a graph for the past 5 years. Based on that, the finance department, our CEO, our CMO, CFO, they will decide the graph of the company, how the profit going in for last 5 years. As a data engineer, we are the one who is working from the scratch itself. From the scratch itself means we have data, but data should not be clean. Data will be on different sources. Let's say we have a company like any shoe company like Adidas. So the Adidas having tie-up with different vendors, different country data and everything. Each of them having data in a separate databases. One member having data in the SQLDB, one member having data in the cloud of AWS or Azure, one member having in the local system like Excel files, CSV. By combining all data, we have to load in a single place. That's why data engineer will do. Load. So we have separate tools to connect with different sources. Like in Azure, we have Data Factory, or in usual we have an Informatica tool on on-premises tool. Based on that, we will connect with the different sources, and then we will bring data, and we will transform data as per the client requirement. Finally, we load in the target environment. From the target environment only, the data analyst will use data for the analysis. Actually, data analysts are the users of data engineer mostly. Data scientist. So most of them got confused. What is data engineer, data scientist? So if you are good at maths, or if you are good at statistics, machine learning things, you can choose data analyst if you wish. Because in, data analysts are the persons who will working on to predict the future of data. For example, for the past 3 years, a person go and buy the milk with the bread on every Wednesday or every Thursday. Means data analyst, data scientists will go and check the pattern of the use buyer's transaction. From that, they will easily predict the next buying properties of the buyer. By the way, they can give some kind of discount, or they can sell some other products with the existing product like milk and butter. This is what data analyst. Data scientists will mostly working on the prediction of the future system. If you are good at maths and statistics, data engineer working on transforming data, and data analyst working on creating insights. The data where data engineer will give. Okay. Yeah, let's start about the foundation of data engineering. So, anyone having any questions on these things? Who's data engineer, data scientist, data analyst? Or if you have any confusion, which role you have to choose, then you can. We will discuss at the end of the session. Okay. Foundation of data engineering. This is the data engineering, not for data engineer role. Whichever role you are going for to work in your future, or if you want to switch from your current domain, first of all, try to be very more familiar with the foundation things, because foundation is the kind of root for every branch. Okay. So as a data engineer, we will, most of them think as data engineer, we will just create a pipeline copying data from source to target. It's not the case. Okay. As data engineer, it's not only copying data from a source to a target. It's apart from, so it's far bigger. We have lots and lots based on the team, based on the company, based on the level in your company, it might be different. What data engineer will do is, first of all, data collection and the ingestion. This is what we discussed before. So we have data in different databases, different places, different environments. From all the things, we will extract data. Extracting, but we are just copying data from all the sources, and we will store in our storage system. Let's say we have data in two sources. One is Salesforce and one is MySQL DB. From the two data sources, we just copy data from them and then storing in our blob storage. Blob storage is nothing but it's one of the services in the Azure. Okay, it's like storing the raw data. Okay, maybe after the slides we will discuss about the services in Azure. You will get some understanding. Blob storage. Getting data from multiple sources and storing in the, this is what data collection, just collecting the data, and then the storage and management. This is what we discussed about it. Blob storage, copying data, and then we will store data in our blob storage. So the storage, what is fine, what is the management? So this is the where the properties of the storage came into picture. For example, we are showing data from the last 5 years, but our plan is to work on the last 2 years data only. So then what about the remaining first 3 years data? So we are not keeping, because even if you are storing a single GB of data, we have to pay for the Azure. That's for the Azure giving some kind of properties like hot layer, cold layer, and the archive layer storage. If you are going to use the data repeatedly, we can store data in the hot layer. If you are going to use data 2 weeks once or 3 weeks once or monthly once, we can store data in the cold layer. Or if you are not going to use data, but we have to give data as a backup, in the time we can store in the archive layer. So based on the layers, the cost will differ. Hot layer is having a more cost per day, more cost for input output transaction. Cold layer is something lower, and the archive layer is very cheaper. So based on that, we can manage the data, storing the raw data and the processed data. So it's not supposed to store only the copy data. After the transformations also, we can store the final data in the storage as well. Okay. Once we store the raw data means data which is collected from the sources, and then we will do transformations. This is where the main literally the 60% of data engineer will came into picture of data transformation service, because data collections, storage, everything we have different tools directly we can use it. But data transformations, we have to use our logical thinking and everything to implement the requirement. Okay. So here we have two different concepts, ETL and ELT. Maybe let me open the notebook. Open this. So we have two different concepts like ETL and the ELT. ETL is nothing but it will extract, transform, and load the data. The extract is nothing but copying data from different sources. So if we have data in different sources, then we can copy from different sources. If we have data in only one source, then we can copy from a single source. Okay. Source is nothing but it's where the place of data already exists. That's it. Because the client will store data in some other place, in their own repository or in their own storage path. From that, we have to do transform, right? We don't have access to connect directly with the client source. So we just copy data from the client to our place, and then we'll start working on it. Transform means data cleaning. Whatever transformation. Transformation is converting the data as per our requirement. Let's say, so in our data, we will have columns like ID, product name, sales, let's say. Okay. So in that, we have to discuss that. Okay, let's say we have date as well. Sold amount. How much the data, the product is sold. So this is the data that we have in the source. Okay. But from the data, we are expecting the output should be in the format like on a date wise, on each date, how much data is sold. Average sales, or let's say it's a total sales. This is the output that we are expecting from this data. So we are not considering about the product, nothing. On each date, let's say for each day, we will have a different product sold. On date wise, we will have to say for the, let's say for today, what is the total amount of sales occurred? For yesterday, what is the total sales? This is what. This is where we are going to transform. This is called transform. So we are writing a specific PySpark code or Python code, SQL, whatever logic. We will write the logic here. We will transform data. Finally, we load into target layer. Target layer is also a kind of a storage. That's it. Because mostly we will copy and the store data in the blob storage for raw data. But in the loading time, we will use the data warehouse. So we will discuss about what is the difference between warehouse and lake here. Okay. Total. So this is how the ETL will work. Then what is ELT? ELT is nothing but it's kind of the same. Extract, we will load first and then we will transform whenever we need. Because not all the data should be transformed immediately at the time of for the requirement. Sometimes we don't need the data to be transformed. We just want to extract it and then load in the environment. Whenever we need in future, then at the time we can go and transform it. This is different between the ELT and the ETL. Simple. So if you want to, for example, for daily sales, we should need the data to be converted on a daily basis. We have to find total sales on daily basis. We don't want to skip the data. We are not going to delay to find the sales. But let's say for the load things. So in some cases, the company or the industry wants to find the aggregation or the sales of the data 3 months or quarterly once or yearly once. At the time, they don't want to transform on daily basis. First, they will extract it and then they load in our in the storage. Whenever they need, they will transform it. That's it. This is the difference between ETL and ELT concept. So based on our client, so the client who we are working, the architecture will be different based on the requirement. Okay. This is where the transformation, cleaning, standardizing. For example, let's say we have two sources. So in source one, we will having two sources. Source one, we will having a data for format like August 19, 2025. In the source 2, we will having a data like the same data but in a different format. So, but anyway, we are going to load both the data in a single column. So to make the data to be standardized, when we are loading, this is in the transformation itself, we will just standardize the data, just formatting it to a same format. Like in this format, we will convert both the data into a same format. That is meaning of standardization and enriching data for usability. Which means based on so we are not getting the all data into the load environment. Okay, so if the client expecting, then we can. The requirement is to finding the total sales on date base. In this scenario, we don't need the idea of product and column, right? That's what. Enriching data, we are getting the necessary data for the usability of the environment. Okay. And once we are building the logic of the ETL, we will create a pipeline. There is a pipeline to extract data from the source to blob storage and then transforming load. Once we write logic, we will create a pipeline to trigger the task. To trigger the task, one task is extracting, one task is transform, and one task is load. So we will create a separate pipeline for them, and then we can load it. Consumption and inside this is what the data analyst will do. In some companies, in Databricks itself, we have a functionality of building dashboards. That itself, we can work on the creating a dashboards and everything. This is the foundation of data engineering concept. Okay. And why Azure? So as I discussed, we have different cloud providers like GCP, AWS, Snowflake, and everything. Why we are going with Azure in the sense, Azure is more because Amazon and GCP having some different business and they are focusing on multiple things. But Azure is mainly focusing on data-driven services. For example, so if we are getting, let's say for a company which we are working, we are getting data of 5 GB a day. Daily we are getting data amount of 5 GB in the service. And suddenly we are getting due to some client putting extra data, some festival seasons, even though if the data volume is getting bigger like 30 GB, 50 GB in a day without any prior information, the Azure can easily able to scale up the resources automatically. It can able to maintain a petabytes of data easily. So in Azure, so they are giving a categorical services, separate services for Azure storages, separate services for the orchestration, specific services for the transformations, architecture warehouse. Even for data analytics as well, we are having special services in Power BI integrated with the Azure itself. So they are integrated the many services in the Azure itself, and the data factory is capable of connecting with 90 plus sources. It's mainly a notable point. We can so we have sources as said, right? We have MySQL DB, Snowflake, Snowflake, SAP, like that. We can able to connect with 90 plus sources in data factory. Azure is offering that services cost optimization. So if you're running a server, so if you're running a cluster, even the cluster is not using or not working means, not running means, Azure is won't cost you. Pay as you go. So if you are running the cluster for 15 minutes, the cost will be for 15 minutes only. The cluster you can easily auto scale. Auto scale means even though if you're getting a more number of data, it will automatically scale up the cluster, increasing the number of nodes. Nodes the same number of systems that work in the backend. It will automatically increase and decrease without any confirmation from the user. It will automatically find based on the AI knowledge that you have. We can have reserved capacity options. We can easily assign the storage for the specific things as well. Okay. For enterprise level projects, mainly companies will focus on the Azure. As I said, we're having a separate services for each and everything. For example, the company is mainly focusing on building pipelines. They need only ADLS and ADF. They don't want Databricks or Power BI thing. They can just go and pay for these two services only. They will use it. Or if they need only for Power BI, they have data ready for the insights. they need only Power BI. At the time, they will go and purchase the Power BI resource only. That's why the enterprise level, they will prefer Azure. Okay. And the AI analytics, they will get so now nowadays Azure is integrating the AI services into the all the services. Using the AI integration, can able to achieve the real-time analytics and the advanced insights. We don't need to create dashboards. If you are giving a single message like a prompt, like create a storage, like create a dashboard, we are using this data, and if you're giving a requirement, it will automatically create the dashboard using the Power BI in the backend. Okay. So we have a different architectures like data warehouse, data lake, data lakehouse. Let's discuss about difference. First of all, let's discuss about data lake. What is data lake? Data lake is nothing but it's like a lake. Let's say we have a kind of lake in our city. In that we can store whatever data. So it's not specific to the. It should be clean data, nothing. So if you're copying from the source to our company storage, mostly we will store data in data lake only. Data lake is a raw data. Okay. Let's say data lake is the storage of a raw data. It should not be a. It need not to be a clean data. In the sense, the data should not have any specific schema, specific column names, nothing. We can just copy data and store the data in data lake. In that case, it's a low cost actually because it's not having any functionalities. We don't have any ASP properties or nothing schema. No need. Just direct copy paste. Even data governance also, we are not giving a row based access, nothing here. Let's say. So we are using this data lake. If we want to directly copy and store data, raw data means which is a non-transformed data or unclaimed data. Okay, that's it. This is what raw data means. Data warehouse. Data warehouse means it's a transformed data. This is where from data warehouse only the data analyst will using the data warehouse as source. For the dashboards or reporting, they will use data warehouse as a source of data. Okay, it's a transformed data, so which means it should be high cost because the transformed data will have specific columns and row levels, everything. So we have different tables in data warehouse. Everything is specific. Yeah, each and column is derived. So if the column is a name data, it should be a string. If it's a number, it should be an integer. Everything is defined here. So this is called data warehouse. So if we want to store the final data, we will store in data warehouse architecture. Then what is data lakehouse? So in data warehouse, we cannot store the raw data. This is the demerits of data warehouse. Let's say if we want to store any data, it should be a transformed data. Should not be raw data. That's the issue with the data warehouse. In data lake, we cannot keep the clean data. That's the demerits. In data lakehouse, it is a combination of warehouse as well as data lake. So it will get the functionality of both the things, and combining both it will have here. We can able to store the raw data as well as the clean data in data lakehouse, and it's slightly less costlier than data warehouse. Actually, data warehouse is more costly, but data lakehouse is less costly. But also in data lakehouse, we will have a functionality like maintaining a version control, time traveling in the previous data. Everything can be achieved with the data lakehouse. You see here, centralized system that stores structured, clean data or organized data for reporting analytics. This is where the stores for data analyst. Okay. We can think like a library where every book is properly labeled categories, which is a cleaned data. Data lake is hold all types of data, whether it should be a raw data, whether it's structured, semi-structured, unstructured, whatever we can store in its original form. This is what we have to see. Original form means we're directly copying from the client environment to our workspace. like storage. Original, we are not doing any transformation, nothing. Just a direct copy paste to the client source. Huge container where you can dump data without worrying about the structure. Structure means schema. The data should not have any proper structure. Okay. Data Lakehouse. It's a modern approach that combines both the worlds, which is data warehouse and data lake. The flexible data lake with the organization and performance of data lake having a flexibility. We can able to store structure, structure, unstructured. But data warehouse, it's optimized. So it's data will be a more performance level. So we can able to query data by using a SQL query itself. Data warehouse. By combining the flexibility and data warehouse, think of a small library having a both messy drafts as well as any published scripts. Depending upon our requirement, we can use the specific architecture, specific storage layer in our project. Here you can see it. Data warehouse is structured data. Okay, so we have data in the source by using ETL concepts, transforming data loading into, we will load the data warehouse, and data analyst will do reporting on it. Data lake is, we will have all kind of data lake. Okay, and then in data lake, after that, some the data lake we will do some ETL. On top of data lake, we will clean because data is not clean. So as part of the transformation purpose, we will clean data and then we will store in the data warehouse. From data lake, we will store in data warehouse, and from data lake we will go for the machine learning data science, because the machine learning engineers or data scientists will more focusing on the unclean data. They will do cleaning because the structured data will help for data analysis, but for the prediction and the predicting the future of sales, they will mainly focusing on the data lake data only. Data lake data only, unclean data. Lakehouse, which is having combining of everything, both warehouse as well as the data lake. In that we will have a layer called governance layer. Based on that, they will control the access of the layers, and then they will use in the future based on it. Okay. For Azure services, what are the services that mainly using? This is the main concept of Azure. Okay, why we are actually using Azure. Okay, let me open it again. Azure services. Okay. First of all, let's focus on the storage. So first of all, we will have a blob storage. Blob storage. So these are the service which I'm writing before I even all services. Okay. So if you go and search the internet, okay, let's see here. Might be, let's say, if you go and search here, the option of services. This is for data factory, DevOps, like that. Everything is service. If you go see the Azure portal, you can just see the services on the website. Okay. Blob storage. Blob storage means which we have to store raw data. Sometimes only I said we have three different storage layers, like hot layer, cold layer, and archive layer, right? And next one is ADLS, which is a Azure Data Lake storage. Data Lake. This is built on top of blob storage, but for enterprise, this is also storing raw data only. But for enterprise level, it's having a functionality of ASIL properties to containing access for the data things. Everything will be captured here. Built on top of blob. So if the user or client not worrying about the privacy of data, they just want to keep the backup of data, they will store in the blob storage. If they want to give access to the data level, or if they want to use the data in the future, or it's a enterprise level project, they will use data lake storage. Okay. And then we have different sources like Cosmos DB. Cosmos DB is used for store the unstructured data. Which is video files or music files, like, okay, video files, images, it will be stored in the Cosmos DB. So we have SQL DB, which is having a transactional data, like row level, column level data, as we know. These are some of the storage accounts that we're using. We are mostly using the blob storage and ADLS. If you're working on the unstructured data, then you can go for the Cosmos DB. And if it's a transaction row level column, we're using a SQL DB as a final, like a target storage account. Once the transformation is done, we will store the data in the SQL DB. Okay. And then for the orchestration services, which is nothing but creating a pipeline. For pipeline, we will use a Azure Data Factory. This is a very important tool. There is a separate roles. Maybe you can see the roles like data engineer. There is separate roles for Azure Data Factory engineer. So if the person who is not willing to code, not familiar with the codings or not like code means, they can go for Data Factory. Data Factory is kind of a drag and drop tool only, but it works on complete orchestration things. We level transformations in Data Factory itself. So depends on the person interest. You can choose a career on Data Factory also. So it's giving a building pipelines.
Prakash, that orchestration mean it is a kind of Kubernetes, clustering setup. No, you have said that orchestration mean what kind of orchestration this is?
No, orchestration is from the end to end. We are going to build a pipeline, right? For the ETL concept that we have, ETL, we extract data from the sources to. I think I have an image here. Let's say, so we will have a data in the source. Let's say we have data in the any sources. Okay, from that we are going to copy in a blob state. It's a blob storage, and then we will do some transformations. Finally, storing in the warehouse. For this complete process to run, we are not going to run the each and every step on daily basis by our manually to make everything automate, because we will write the logic for every layers. So if we run the pipeline from our side only one, or we can schedule the pipeline, it should be triggered on daily at 6 a.m. or 7 a.m. or for every 2 hours in a day it should run means. This is what the orchestration concept will involve. It's just creating a pipeline to make the complete process to automate end to end. So if you get the pipeline data factory, once we triggered it, it will automatically copy the data from source to our blob storage, and then it will start transforming the data. Finally, it will store data in the SQL DB. The same process will happening on a daily basis. Whenever, as per our schedule information, we can able to do it. In data factory, we will have a different activities.
But how it is working without any code, SQL and Python code? Without coding, it is working. Drag and drop.
No. So the coding, the transforming part, we should write actually. Okay, we should write in the coding. But most of the companies having data ready in the source itself. They are having the clean data. So it's not a condition. Okay, like in the raw data should not be always unstructured or unclean. Sometimes the client will give the clean data as well. What they actually did is they want to just copy data from the source to the target layer. From that, they are having some very minimum level of transformations, adding a new column or removing a column, concatenating a column, or changing data type of the column. These are the functions they might have. Let me show you the one of the activities. So in, let's say, yeah. So in the data factory itself, it's having a different activities for each and everything. Check file. Check file means whether the specific files are available in the path or not. Write result. It's storing data in the things. Delay. So if you mentioning delay activity, even if we don't have any data in the input, we're using delay. So we can ask the pipeline delay for 5 minutes or 10 minutes until data will arrive. If anything failure, we can do log on fail. All the things we can do in the coding as well, Python or PySpark. Instead of going with the data factory is capable of maintaining a minor level of transformations only. So if you are focusing on optimize the level of data handling, you should go with the coding. Okay. First of all, a person who is switching from non-IT to IT domain or somehow support to data engineering, they will be bit not familiar with the coding concepts. At the time, they will first focus on data factory and the SQL concepts, and then once they're familiar with this, they can go and find the path for the PySpark and Python and everything. For each
Okay.
activities, we are for each levels we are having a separate. So let's say in Azure Data Factory we have one activity like copy activity. So in the PySpark we can able to write the data to connect with the source, and then to copy data we have to write separate logic. For this we have to write the logic of 7 to 8 lines connecting it. But in Data Factory there is an option to connect with the source directly. Just click on the Salesforce and connect. It will connect using the username password. Just dragging and drop the copy activity. If you see here, we have a copy activity here, copy data activity. Based on it, we just want to mention the from source and sync, from where we are copying and where we are pasting data. And we have some settings. If we need, we can pair. Let's say we have a 1 GB of data, but we have to copy it as fast as possible. Just enable a parallelism. Data will be copying in the parallel. Like that, we just want to do a learning about the activities. There is no coding required for Data Factory. Okay. But the real-time concepts will be more important for Data Factory concepts. What else? Data Factory is a pipeline orchestration. Databricks came into picture for transformation. So if we are focusing on a major level of transformations, or let's say the data volume is very high, like it's 50 GB or 70 GB, we should go for Databricks only, because in Databricks it's built on top of a Spark, Apache Spark, which is a framework for a parallel processing. Okay, data processing. For that we can go for Databricks. Databricks is a user-friendly environment. In that you can create a clusters at any size, and then we can handle the data. Synapse Analytics is a combination of data warehouse. In the Synapse Analytics, it's a enterprise level services. In Synapse itself, we can able to see the data orchestration, data storage, Power BI, everything will be involved here. So if you want to use all the services in a single place, we can go for the Synapse Analytics. It's mainly a warehousing tool, storing data in the warehouse format. Under Power BI, we have a Power BI service in Azure. We can use it for visualization or insights. Okay.
నీకు పాయసం చేసి పెడదామని.
Yeah.
Yes, Prakash, you can go ahead.
Okay. So we have a Medallion Architecture. So in Medallion Architecture, so it's a real-time architecture. So we have some other architectures like Lambda architecture, Kappa architecture. It's nothing but how we are handling a data. Most of the companies do rely on the Medallion architecture only. Okay, so it's nothing but we have 3 layers: bronze layer, silver layer, and gold layer. Bronze layer means just directly copying the raw data into a storage format. As we said, we are not doing any transformation. Just copy the client data and storing in our blob storage. This is called bronze layer. And then silver layer means where we are doing the transformations. We are removing the columns, cleaning the data, removing the null values, standardizing the data formats into a single format. Everything will be doing in the silver. In the silver layer, we are not doing any aggregations. Aggregation means finding total sales, average sales, counting the number of customers. Nothing will be, just the cleaning and the doing. Apart from the aggregations, everything will be captured here. Gold layer means the place where we are doing the aggregation. Aggregated data. We will do the kind of some average count. All the things will be captured in the aggregation gold layer only. This is for if we have data sources. We will have first of all we copy into our bronze layer, and then we do some kind of transformations, aggregation. Finally, we load in the SQL DB data warehouse parallel. Okay, after the gold layer. From the storage, data analyst team will, or the client or user, we can directly use the data. Sorry. If you see here, you can get some understanding. So we have 2 types of processing: only batch processing and only stream processing. Batch is we are running the pipeline, right? Pipeline concept. Pipeline will run for every half an hour, 1 day, or 1 week, 1 month. The data which need to be captured on a specific time interval is called batch processing. The live data capturing is streaming. The share market data, the gold data will be covered in the streaming concepts. Data will be captured on both is having a separate architecture. For the batch processing only, we are using Medallion architecture. But for the streaming, there's different architectures like kappa architecture, lambda architecture. Might be if getting chance, we will discuss in the next session. So if you're planning for next session on this, okay. Raw data, everything will be captured here. This is the same architecture that we discussed here. Okay, Medallion architecture. Okay, let me discuss what we actually did in the formats. I hope that Databricks screen is visible. Databricks offering a community edition, okay, community edition to practice Databricks environment, which is a free actually, so you can use it. So whenever we are running any notebook or we are loading any data, we need a cluster to start. Without a cluster, we can't do anything in the Databricks. And also, community edition is very limited, so we can able to get only one cluster at a time. So I'm just creating a cluster under my own. So it will take around 1 or 2 minutes to start. In the meantime, we will create a notebook. Notebook, if you see in the workspace, so we can create a notebook. Notebook is a place, it's just a file, okay. The place where we are going to write a code. Databricks is nothing but it's built on top of a Spark. Previously, we have an Apache Spark framework. In that, we have to go and write the code in the command prompt. So Databricks is built on top of Spark, which is act as a UI. It's a very competitive tool in the market. Okay, if you are applying for data engineer role without knowing Databricks tool, it's quite difficult to get a job. Getting a notebook. Let's name it as next gen data engineer. So just for our reference. Okay. The cluster is starting. If you see here, our cluster is starting, which we created. Okay, in the meantime, let me import a Spark then. So if you are working for the database account, first of all we have to install these libraries. So here I'm not going to cover from the basics or nothing. Just I want to show how the real-time architecture will work. Okay, because it's a quite large topic to discuss, so I want to make it clear. So it's not a big thing. It's just a directly easy way to convert data. So if you're clicking the control enter, or you can go and click this icon to run this cell. It will run on this cluster. Now the cell is running on this cluster. Okay, that's why if you see here, the cluster is active now. Now it's got it. Or if you're giving any wrong things, it will throw error here. Okay. Now the Spark session is imported. So these are the standard steps. Okay, first of all, we have to import a Spark session, and then we have to create a specific variable by storing this Spark session. This is a common syntax, so don't worry about. Okay, so it's not difficult nothing. It's a common syntax that everyone will follow. Just I name it as demo, as we are doing some demo sessions that are created. That's it. Now the Spark session, I just assigned it in the Spark. It's not necessary. Wherever you are using it, you have to use this complete one. Instead, I just throwing everything in the Spark variable, and then I'm going to write a code now. I already have the data ready here. It's a sample data. Let's assume that this is the data that we have in the client environment. For now, it's not connecting with anything because in community edition, they don't allow for connecting anything. Okay. Let's assume this is data that we have in the client environment. Okay. From the client environment, now we are going to just paste in the bronze layer. Bronze layer is nothing but it's a directly storing data in the without any modification. We are just storing data. Let's assume this is the columns. We have a ID column, product name, product category, how much sales product cost, how much it say happened on the specific date. Okay. Now I'm creating a branch here. DF is nothing but data frame. Okay. We generally Spark before here. Wherever we are writing a function in the Databricks, we have to mention the Spark here. Now I'm going to convert this complete data into data frame. Data frame is nothing but it's kind of table, like a row and column format. Right here we are having a comma separated everything. I just want to store in the table format. This is syntax. Spark.create data frame and then data, which is this one, this variable data, and we have to mention the column names. I'm mentioning the column names in the column variable here. Data, comma, columns. Now I'm just running it. Done. If you want to show this data, how it's loaded in the backend, that's it. Now the data is stored in the branch DF. This is our data. Now the data is available in the table format. If you see here. Now from this we can do our transformations and everything. So here what I'm trying to do is finding the products which is having the sales amount, let's say more than 100. We have a sales amount less than 100 somewhere, and just want to filter it. That is, I'm just calling it as a silver layer, creating a one more layer, one more thing. So I'm just going to filter the bronze level data. So bronze df dot filter. So if we are going to work on any columns, let's say I'm going to filter on the column of sales amount. So we have to import one more function, because so if you are going to work on any column means we have to import one more function. From the SQL.functions, I'm importing a call function. So we can now easily type here. What is the column name here? Sale amount. Okay. I'm just taking the amount which are more than 100, and then I'm printing it. There is some issue here. What is that?
Prakash, filter spelling mistake.
Sorry, filter. Thank you. Okay, this is the command. So on top of, so previously we have data, and then we saved data in data frame. Branch here, we stored our data in the data frame, and then we are seeing it by dot show command. We are seeing it from this branch layer and just filtering it out the sales amount which are 100. If you see here, previously we had 20 plus records. Now some of the records got skipped because those records are let's say we are 1200. I just want to the records which is more than 1000 means you can see these two records only. Okay. As I said, in the gold layer, what we will do is we will do the aggregations. Now on top of our silver data frame, I'm just group by. So anyway, the aggregations will be on based on the each date, based on the date level or the product level. Let's say we have a different dates for all days. So we have a laptop. So I'm just want to find the total sales of each product base. What is total sales of laptop, mobile, and headphones? So there is a functionality called group by. Grouping means we just categorizing name. That's it. Group by product name. I want to sum the sales amount. Don't worry about the syntax. Okay, it's quite easier. So if you are practicing it for 2 days, you can familiarize with it. So I want to name this column. So name this column. How I want to rename the column. This is the sales amount. Now I'm going to name it as total sales. For that we have a so I just want to name this column. Currently this is sales amount. Now I'm going to get the total sales, right? So I just want to name this column as total sales. So here I don't want to mention column. Let's name it as total sales. It's just a column rename. Currently we are having a total sale amount as column name. I just want to rename it as total sales. That's it. Let me run it. It got succeeded. Now if you see here, we are for each product we will getting the total sales. Here's the name that we renamed. Everything will be captured here. This is how the layers working. So here we are just doing all the layers as a single notebook, but in a real-time manner. For bronze layer, we will have separate notebook. For the silver layer, because here we are doing only filter only. In real time, they will do some data cleaning, standardization, normalization, optimization things, catching, everything will be. For silver notebook is usually a bigger one. Gold DF, because for bronze it's just the direct copy paste, okay, data. That is nothing big in the code. Silver layer and the gold layer are important. This is how it works. So here we are just showing data frame. So if needed, we can store data in a specific tables or specific storage path, mount point, anything. Okay. This is how the real time works. This is the architecture that we discussed here: bronze layer, silver layer, gold layer. Okay, so I'm just done with my session. If anyone have any doubts, then we will discuss.
Yeah, yes, thank you, Prakash. Thanks for a very interactive session.
Thank you very much.
So first we can do we can take a couple of questions, then we can go for quiz. So first there is a one question from just a minute. So there is a question from Bhavya: when to use ETL and when to use ELT?
Yeah, so we have to use ETL if we want to transform the data always. Or sometimes the client is not requiring to transformation. All they need is they just want to store the data in the data storage. They are planning to transform the data whenever they need. Let's say we have a couple of fruits in the job. We want to go and extract the fruit, and we will create a juice bottle on a daily basis. In that case, it's a ETL. Or the manufacturer company want to bring the fruits orange from the trees, and they just store in the godown for 6 months. After 6 months only, they are planning to prepare a juice. This is the difference based on a client environment. If they don't want to transform, they will simply load it. Okay.
Okay, first the requirement will come first ETL or ADF. How the requirement will come? Because we don't know, right?
No, so don't confuse among the ETL and the ADF. Okay, ADF is a tool. ETL is a concept actually.
Yes, yes, correct. Nagaraj, ETL is a process. ADF is a tool. Correct, correct. I agree, Prakash.
Yes, by using ADF also we can do ETL, because ADF is connecting with the sources. It's kind of extraction. In ADF
Okay,
we can do some transformations.
Okay, we are applying the concept in the ADF as a tool.
We can do ETL in both ADF as well as in Databricks. So in the last demo session, we do some transformations, right? We extract data and we load in silver. Finally, we load in the gold layer. It's also kind of ETL. ETL is a process where we are using is a matter.
But you load finally gold layer, but the last is a business read. How we will give to business read?
Yeah, that's what I said. So for finally we add in the gold DF, right? Finally after gold DF, we are storing it in a table. So
Okay,
there is
okay.
separate syntax to store, like goldf dot save as table, and then we have to mention the table name. If you mention and run it, data will be stored in the specific Azure DB.
Oh, Azure
From the
DB.
Azure
Okay.
table, yeah.
The final one you did that group by and all na, that will be so you created a raw data too, and you created a data framework, correct? Right? Data frame. You
Yes,
create a
correct,
data
correct.
frame, raw data, and you made the structure using a, data frame. Finally, you did one transformation like group by and all you used, and the gold layer you applied. It will be stored in Cosmo DB or which DB?
Yeah, based on our preference. For now, we are using a transactional data, right? So here we are working on a product level sales, which is a column and the row level data, transactional
Okay.
data. This won't be stored in the Cosmos DB. Cosmos DB is capable of storing the images, videos, like unstructured data. If you
Okay.
want to
It's a
store the
no SQL
structured
DB.
data, yeah, no SQL DB. If you want to store the structured data, we can go for the SQL DB, Azure SQL DB.
Okay.
Yeah.
Yeah.
Next
So that
question.
snaps, when we will use snaps and all.
Yeah, Synapse is completely a enterprise level tool. So if you want to store data in like all the orchestration, data transforming, Power BI, everything will be captured in a single environment. Means in that case we can go for Synapse. Mostly company prefer Synapse. So if they want everything in a single workspace, mostly
Okay.
company preferring a different services like ADLS, Databricks, Power BI separately.
Okay. In that Databricks, first you imported that library, 𝒆𝒔𝒔𝒊𝒈𝒉𝒕🔥 library .SQL. Some second one Spark and all. Now why that one we need?
So since we are working on community edition, right? So we have to go and import it every time. But when you're going for real time manner, the Spark and all installed in the cluster itself, backend. So we know
Oh,
need to
okay.
install the things.
So that's why
Yeah.
you mentioned that Spark something, right?
Yes, correct. The Spark session, we have to install the community edition. So if you go for the real-time things, all the things will be in the backend itself they install, because everyone will work on a Spark only in Databricks. So they
Okay.
will install in the assembly prerequisites.
Yeah, yeah.
Okay.
Yeah.
Okay.
So okay, Nagraj. Thanks for asking questions and thank you, Prakash. And let's start quiz. So let me share my screen. Everyone requesting, please be ready your mobile with your mobile. Let me share my screen. So before displaying the quiz, just I am going to tell you about our next session. NDAC will be hosting next session on next Saturday, which is on 6th September. The speaker is Nandan Hegde. He is a Microsoft Data MVP, and he is going to talk about data access and integration with shortcuts and mirroring in the Microsoft Fabric, which is a very interactive session. So already this link is shared in the Teams chat. Please go through this and please register for this session. Now I am displaying the quiz. So please scan this QR code or go to this slido.com and enter this code. Yeah, yes. First migration, thank you. Please enter your name. Because those who are attending from desktop directly scan the QR code. Those who are attending from mobile, you can just go to slido.com and enter that code. Okay, very good. We have 37 people, so excluding organizers 35 are there. I'm expecting minimum 20 to 25 people to enroll this quiz. Okay, Rahul. Okay. Okay, let's wait 1 more minute. Because I'm seeing 37 people. So let's wait 1 or 2 minutes. because this quiz should be very interactive and very competitive. Okay, come on, 3 more people. I'm expecting 3 more people. It's already count 22. Those who are not able to scan the QR code, just go to this slido.com and enter this code. $23. Okay, no problem. So let's start. So please look on your mobile screens. I'm launching first question. Please look on your mobile screens, not on desktop. Yes, the first question is here. Five, 4, 3, 2, 1. Time is up. Wow. Okay. Almost you guessed correct answer. So let's see what is the correct answer. Okay. So the correct answer is ADLS. Let's see the leaderboard. Vignesh. Okay. So next I'm launching next question. Five, 4, 3, 2, 1. Time is up. Okay, very good. So let's see the correct answer. Yes, let's see the leaderboard. Okay. Okay, fine. I'm launching the third question. Please look on your mobiles. Okay. Okay, most of you are answered correctly, but anyhow, let's see the correct answer. Okay. So the leaderboard is still leading with Vignesh. So I'm launching the fourth question. Which of the following is not listed as a core Azure data service in this session? Okay. So let's see the answer. The answer is Azure Cosmos DB. Let's see the leaderboard now. Okay, Kavya, very good. Very good. Okay, so now I'm launching the final question. Be ready with your mobiles. The final question is here. Okay, fine. Okay, most of you are guessed correctly. So let me see the leaderboard. Okay. Yeah. Yes, Kavya. Kavya is the winner of this question. Congratulations, Kavya. Congratulations. And Magdeshan, are you there in the call?
Yes, Suparna. Yes, I am there.
Yeah, could you please collect Kavya details?
Yeah, sure.
Sure. Okay. Congratulations, Kavya. So let me stop my screen share and we can continue Q&A. If you have any questions, please feel free to ask. So Prakash is here. He can able to answer all of your questions. So no questions.
Hi, Suparna. This is Rahul.
Hey,
Just
hi
one
Rahul.
question
How are
for
you?
Prakash. All good,
Yeah.
all good. Yeah, I'm
Yeah.
happy to see your, progress, Suparna. Hope you remember me.
Yeah. I remember you.
Yeah. Okay. So my question is regarding the Medallion architecture. So, what is the major deciding factor to go with Medallion architecture instead of, some other, models, data design models?
Yeah, so if you are focusing on the batch processing, as I said, right, we have a 2000 kinds. One is batch and one is streaming. So if you are focusing
Yeah.
on batch level processing and we have a unstructured data, like not unstructured, unclean data, in that case we can go prefer Medallion architecture. So here we can have the different layers because we have bronze layer, silver layer, gold layer. So if the data analyst want to go and check the data specifically on silver layer, we can give access for the silver layer. Or if the data scientist come and wants to see the unclean data, we will give access to the bronze layer. Okay, so since we are having data in different layers, we can use the data as per the requirements. That's where we are using Medallion architecture.
Okay, so what I was thinking is like, is there anything that we consider while picking up this particular data architecture model? Like we have many other architecture designs, right? So is there any deciding factor? Should we go with Medallion or anything else? Apart from, of course,
Yes.
I understood the structures of our Medallion, but yeah, is there anything else that
Yeah,
will be a
so
major
we have
factor?
some more architectures like Lambda architecture, Kappa architecture. Like
Okay.
Lambda architecture is mainly focusing on real-time data, like the share market data, right?
Okay.
So the classes will always on. So if the client's requirement is